A star gets devoured by a supermassive black hole. One of these events only takes place a few times every 100,000 years in a galaxy that has a dormant black hole at its center. Nonetheless, the Hubble Space Telescope was able to catch one of these events not too long ago. When some stars reach the end of their lives, they go out with a bang, literally, exploding in a massive supernova. However, some stars go out with a whimper, blowing up and spewing out material before contracting and cooling to a small core. But every so often, a star will meet a more tragic end when it is torn apart and consumed by a voracious black hole. This occurs extremely infrequently. One of these events only takes place a few times per 100,000 years in a galaxy that has a sleeping black hole at its center. But the Hubble Space Telescope was able to catch one of these events not too long ago. Researchers were able to see the final few moments of a star's life when it was swallowed by a black hole approximately 300 million light-years away. The event, which was given the designation AT2022 DSB, was a flash of light that was emitted when the star got too close to the black hole. The occurrence known as tidal disruption, in which a star is torn apart by a black hole, is brought about by the enormous gravitational pull of a supermassive black hole. Huge black holes like this can be found at the heart of galaxies, and they have the ability to strip layers of gas off any stars that go too close to them. After some time, the star will be fully destroyed, and the remnants of it will be pushed into an accretion disk, which is a disk of matter that orbits the black hole and provides the source of the black hole's nutrition. At the meeting of the American Astronomical Society on Thursday, January 12, one of the researchers, Emily Engelthaler of the Harvard and Smithsonian Center for Astrophysics, noted that black holes are quite messy eaters. They are devouring this accretion disk, which is shaped like a donut, from the inside, and because they are consuming too much and spewing out radiation while doing so, this accretion disk is puffing up into a lovely, big, fat donut. The research focused on the radiation that is coming through the accretion disk itself rather than the radiation that is being emitted by jets, which are one type of the radiation that is emitted when these events occur. The researchers examined the ultraviolet light emanating from the star by utilizing Hubble and the scientific method known as spectroscopy to separate the light into its component wavelengths in order to determine which wavelengths had been taken in. This makes it possible for them to determine what kind of elements were present and to piece together hints about what is going on inside the brilliant, hot chaos that surrounds the black hole. Because of how readily this wavelength can be blocked, it is not very often that such events are recorded in the ultraviolet. As a result, it is difficult to collect data on this wavelength. It was necessary to have a telescope that was located beyond the atmosphere of Earth. Quote, ultraviolet light has a very difficult time penetrating atmospheres, which is excellent news for us, but awful news for observers. Therefore, we will need to employ a telescope in orbit. End quote, Engelthaler explained. Because the scientists were interested in determining how the star and the black hole evolved over time, they carried out a series of observations that spanned a number of months. They discovered that the temperatures in the disk decreased over time and that star winds were blowing away from the event and toward us at incredible rates of 20 million miles per hour, which is equivalent to 3% of the speed of light. The spectra that the researchers gathered, on the other hand, were not stable. Rather, they displayed a significant amount of variation over time. It's possible that this is simply due to the fact that the source being investigated is located at a greater distance, which caused the signal to become obscured by the noise. Or it's possible that the material surrounding the black hole shrunk, causing a reaction in the amount of matter that was sucked in by the hole. This would result in a donut-shaped region of less material. The researchers are making steady progress in analyzing all of the data they have gathered. Peter Maxim, an additional researcher, was quoted as saying in a statement that, quote, "We really are still getting our heads around the event," end quote, If you tear the star, then it will have all of this material that is falling into the black hole. And so, you have models in which you think you would know what's going on. And you also have what you actually see happening in the world. Indeed, it is a wonderful time to be a scientist right now, because you get to work right at the border between the known and the unknown. What do you think? Can you imagine what a star that is getting devoured by a supermassive black hole looks like to the naked eye? Comment your thoughts below. Thank you so much for watching the video. Don't miss out on our latest uploads. If you wish to stay up to date with the latest space updates and discoveries, hit the subscribe button, like the video, and turn on all notifications to see more of our latest videos in the future.